start the recording, right? So sometimes horizontal limits get weird. So I'm going to open this up. Be brave. Got your microphone on and answer the question. How many horizontal asymptotes can you have in a problem? So given a function, how many horizontal asymptotes can you have? I want you to think back, like, because you've had to graph tons of stuff with horizontal asymptotes. How many horizontal asymptotes can you have? Now, if I were sitting in class, I would be thinking, every problem I've ever seen has one horizontal asymptote. Right? Every problem, if you graphed them in Algebra 2, you only had one. Okay? Just curious, why would you say 2? Trying to create a dialogue. Of course, I'm recording a dead space.
I feel like I remember there being 2 back in Algebra 2. I feel like I remember there being questions where we did have 2.
I don't think you didn't have 2 in Algebra 2. I don't think you had 2 in pre-calc. It's very hard, right? So I want you to think of, here's how I want you to think of horizontal asymptotes. I want you to think of horizontal asymptotes as end behavior, because that's exactly what they are. They're describing what's happening at the end. So if I go all the way to the right, right, that's what my horizontal asymptote is usually all the way to the right, and we kind of just by default saying, well, that's the same as I go all the way to the left. But I want you to think of since horizontal asymptotes are in behavior, think about every graph you've ever done. It's got 2 ends. It's got a right end, it's got a left end. And since it's got a right end, it's got a left end, that means you could have 2 different horizontal asymptotes. But you've never seen something with 2 horizontal asymptotes. Different ones. And I was like, actually, you have. I want to talk about this little graph again. Oh, just for fun, everybody turn your cameras on because I want hand motions, and I can't see hand motions if I see black squares. Come on, turn your camera. You're not being recorded. Only I'm being recorded. If you can, turn your cameras on. Come on. Let me see if I can. Yay! There we go. Trying to create some, yeah, that's so much better. Let me see if I can. I've got a few. I need a few more so I can actually do the large gallery. All right. So, there we go. What does this look like? With hands, right? Can everybody show with hands what it looks like? This. That's what it looks like. Whenever you see x over absolute value of x or the other, you get this picture. All right? Now, if you don't believe me, you can plot points. I can do a little XY chart. I can plug in 1, 2, 3, and 1 over absolute value is 1, 2 over absolute value is 2, 3 over absolute value is 3. It's a little more interesting at -1 because then I get -1 over 1, which gives you -1, and -2 also gives you -1. So we end up with this little picture that every place to the right is at 1 and every place to the left is at -1. And as weird as this sounds, this has 2 different horizontal asymptotes. right? As I go to the right, the y value this gets close to, my end behavior is 1. As I go to the left, my end behavior is -1. So this is like, if this is my function, if I asked you, what's the limit, I asked you a marker that writes, what's the limit as x approaches positive infinity of x over the absolute value of x? We're going to say 1. And what's my limit as x approaches negative infinity of x over the absolute value of x? That's going to be -1. And anytime you see this notation, limit as x goes to infinity or negative infinity, they are talking about horizontal asymptotes. They're talking about end behavior. What's happening at this end versus what happened at this end. And since we have two ends, we can have two horizontal asymptotes. All right, fine, right? What does this have to do with anything, right? Like, I mean, okay, fine, okay. You accept that we have two horizontal asymptotes, right? You can accept that. But what do the questions look like? Because I'm not going to give you a question like this, right? What do the questions look like? Well, before we talk about what the questions look like, let's talk about something that your Algebra 2 teacher may or may not have talked about. And I'm going to cut the Algebra 2 secret some slack because I'm guilty of this too. I need to talk about Algebra 2 topic. What's the square root of x squared? Any brave soul want to give me an answer?
X.
Almost.
Or negative x.
No. But you're on the right track.
Also minus x?
Better. All right. Thanks for the participation. It helps. All right. I like hearing student voices. So you go through. Now, to be fair, when I teach this in Algebra 2, I really don't want to get into this detail. So I just basically say, hey, square root cancels out the square. You get to write x and you're done. Right. That's how I do the problem. But that's really not what happens. Before we talk about answering this question, I want to talk about this question. What's the square root of 9? You don't have to write this down. This is just crazy teacher talking. What's the square root of 9?
3.
3. Okay. Just curious. You can just raise your hand if nobody else will see it except me, right? Because everybody should have me pinned, right? How many think, anytime you see square root of something, you think it might be plus or minus? Because I want to deal with that right now. Does anybody think that anytime you see the square root of something, it might be plus or minus? Right? Because, like, that usually happens, right? You have a square root, right? So let's talk about when you get a plus or minus and when you don't. You get a plus or minus if you have to solve an equation. If I said x squared is equal to 9, and I asked you to solve it, right? Your job is to figure out, when you take square root of both sides, you have to put plus or minus, all right? That should sound familiar. That's what your algebra teachers do, right? But if it's just a square root button, if you type square root of 9 in your calculator, does your calculator tell you plus or minus 3? Like, think about it. If you typed in square root, right? If you just type in square root of 9 in your calculator, does it tell you plus or minus 3? Of course not. It just tells you 3, and here's why. They have defined anytime you take the square root of something, it has to be positive, right? And the reason they define it that way, right? It's a function. See, that's how functions work. Functions only give you one answer, right? When you type, and even on your calculator, they're called function keys, meaning they're only going to give you one answer. Since they can only give you one answer, they have defined square root as positive. Why am I saying all that? Well, you have to guarantee anytime you see a square root, you have to guarantee it's positive. And if you see the square root of x squared and you just write x, that doesn't guarantee that it's positive. Right? So, turns out what I should do as an Algebra 2 teacher, and I don't, and what your Algebra 2 teachers should have done, and they may not have, they may have and you forgot about it. Anytime you take the absolute value of something squared, you have to guarantee it's positive, so we have to put absolute value bars around it. Okay, fine. So what does that have to do with anything I've talked about with limits, right? That doesn't seem to have anything to do with limits. Well, here's where. So now you want to take notes on this next part. You know, everything up to here, not so much. But now you want to write the examples down. What if I asked, what's the limit? I need to throw this marker away. Just so you know, it went in the trash can. I know y'all can't see, but it went in. And it was a long way away. I mean, we're talking 15 feet, and it just did swish. It was awesome. Okay. So, So if I want to do the limit as x goes to infinity, and I'll do an easier problem. Let's say I have 2x plus 3 over the square root of x squared minus 4x plus 5. Let's talk about this problem. If I'm going to talk about this problem, I need to talk about its sibling, which is going to be the limit as x goes to negative infinity of 2x plus 3 over the square root of x squared minus 4x plus 5. All right, so what do I have? Introduce ugly function, right? Got square roots and everything else, right? I don't want to graph this, and I'm not asking you to graph this. I'm asking, what's the limit as I go all the way to the right? And then what's the limit as I go all the way to the left? And when I teach this in 6th period, I will actually put this problem on the left and this problem on the right. I did not plan how to put things on the board. Sorry. Right? But let's talk about how we compute this. Well, how you compute it, kind of the shortcut with computing limits is when x gets huge, stuff doesn't matter, right? When x is huge, what's your most important term on top? Wait, can y'all read that? Can y'all read this? Okay. So when x is huge, does a 3 matter? You can shake your head. Okay. So when x is huge, that 3 doesn't matter. All right, so I get to ignore it. So I get to say, okay, that's going to be the limit as x gets big. So my most important term on top is 2x. And when x is huge on the bottom, what's left? What doesn't matter? What goes away, right? When x is huge, 5 doesn't matter. Same thing, when x is huge, big number squared is way bigger than just 4 times a number. So when x is huge, this stuff goes away. And so what I'm left with is the square root of x squared. Because when x gets huge, stuff goes away. All right. Oh, wait a minute. What's the square root of x squared? That was right? Remember the square root of x squared, we had this massive conversation that square root of x squared is the absolute value of x. So this is now same thing as the limit as x approaches infinity of 2x over the absolute value of x. And now, after we've sort of thought about this, we can now answer the question. Now, do we know what the graph here? Does everybody remember what the graph of x over absolute value of x looks like? Okay. What happens when I multiply that by 2? What happens to this? Right. It goes from being at 1 and negative 1 to 2 and negative 2. Right? So, what's our limit as x goes to infinity of this thing going to be? You can hold up hands. 2, right? Is everybody okay? We're going to 2? Because, in my mind, this picture looks like, okay, we're at 2, we're at negative 2, so this side's doing this side's doing this. I don't care what's happening here. I care about the end. I care about what's happening as I go all the way to the right. And as I go all the way to the right, this guy goes to 2. That's not the interesting question. This is not the question people miss. This is the question people miss. Because you still do the same logic, right? You keep going through this whole thing. It's like, okay, this doesn't matter, right? And we could do this in our head. You don't have to write all the little steps out that I did. Like, I actually look at this and say, oh, well, okay, that's going to give me the limit as x goes to negative infinity. I get a 2x over square root of x squared. It's going to give me absolute value of x. But now what's the difference? We're not going to the right. We're going this way. And if I go this way, what does that become? Is it +1 or -1?
Negative.
All right, because when you remember that graph, x over absolute value of x, this is a big fat -1 times 2. So this gets me -2. All right. Now, I did a whole lot of talking, an awful lot of talking, for something that once you get the idea is instant. Just like computing a horizontal asymptote, I did a whole lot of talking, and your teachers in previous years did a whole lot of talking. But right now, hopefully, you can just look at sort of a basic rational function and go, oh, well, this is the horizontal asymptote. I don't have to do any work. It's because the teacher, but I had to do a whole lot of talking initially. The same thing happens here. The warning is anytime you have the square of an x squared, that's going to create an absolute value. And when that creates the absolute value of x, that means you're going to have this picture. So you get different horizontal asymptotes. As you go to the right, you're going to get something different as you go to the left. All right, so this is an example of an easy one. What does it look like when it gets harder? So, what if I give you the limit as x approaches infinity? Actually, I'll set this one up properly. So I'll do the limit as x approaches infinity as I go to the right of 4x minus 2 over the square root of 9x squared plus, and this one's going to be the limit as I go to negative infinity of the same thing. So I'm going to the right, then I'm going to the left. Let's talk about the right, because this is the one, if I didn't teach anything, you get it right. This is the one, if I didn't teach something, you'd probably get it wrong. All right. Okay, does everybody write down it? Okay, just for fun, laughs, and giggles. All right, if you've written this problem down, go ahead and write down your answer. Just write down your answer, right? I can't see it because it would be creepy if I showed up at your house. Okay? So, you look at it. What happens when x gets big? This stuff doesn't matter, so it goes away. I don't care about it. So, I end up with, okay, this is the limit as x approaches infinity. I get a 4x. On the bottom, I get the square root of 3x squared. I mean, the square root of 9x squared. Oh, well, square root of 9 is 3, and then I get the absolute value of x. As I go to the right, this is effectively a big fat positive 1 because we're going to the right. And then I end up with 1 times whatever's left over, and I get a 4/3. Anyone want to be brave and tell me what the answer to this one is? Negative of that, right? Because, I mean, can you see that we're going to get that x over absolute value x part? Like, if I go through this, it's like, oh, well, that's 4x. That's going to give me 3 absolute value of x. But now, since I'm going x goes to negative infinity, this is now going, this is going to be a big fat negative 1, so I end up with negative 4/3. And like, hopefully at this point you're looking at it, go, okay, this isn't that bad, but if I didn't have this talk, I think it would be hard to get that right on your own. All right, there. So try this one. Got a couple that I want you to try. Oh yeah. And I'll try to write them neatly and hopefully large enough so you can see it. So I'm interested in what's the limit as x approaches negative infinity of negative. So I'll give you a couple of minutes to copy those down and do that. There we go. All right, it goes to negative infinity. This stuff doesn't matter, right? I only care about my highest exponent, so this doesn't matter. So I'm left with the limit as x approaches negative infinity. I get a negative 2x cubed over the square root of 11 times x cubed, and there's an absolute value, because I have to guarantee that it's positive. And so you might think, well, what's x cubed over the absolute value of x cubed? It's still this. Positive 1 as I go to the right, negative 1 as I go to the left. Right? So what ends up happening is, because I'm going to the left, this is a big fat negative 1. And so I do negative 1 times all this. I end up with positive 2 over the square root of 11. Let's sort of deal with this now. I know your Algebra 2 teachers and your pre-cal teachers are really adamant about you can't have a square root in the bottom. You can. There's nothing illegal about it. If I've got time, I'll tell you why we do it. But like you can even, there's some answers in the back of your textbook when you check. There's a square root in the bottom, so it's fine to have a square root in the bottom. You can leave your answer that way. Next, let's look at this one. So let's say that I have, this is going to be the limit as x goes to negative infinity. Again, this goes away, so I get negative 5x squared. I get square root of 11 times the absolute value of x cubed. This one, on the other hand, is a little different because it's bottom heavy, right? More x's in the bottom. So this is going to go to 0. Anytime you go bottom heavy, it goes to 0. So it doesn't even matter if it's positive or negative. I just put the negative in there to try to fool you. One more example about limits at infinity. Actually, two more. Yeah, and then I'll have you do a Khan Academy, which the one I assigned Thursday or Tuesday, and then there's some homework. So, what's the limit as x approaches infinity of sine x? In calculus, we just start asking some weird stuff, and like, okay, we do limits with like polynomial type things. What happens when you do trig? So let's talk about what this is asking. This is asking, as I go all the way to the right, what y value do I get close to? Well, if our picture of sine looks, this is my picture of sine. Am I getting close to any particular value as I go all the way to the right? I'm not. It's just going between 1 and negative 1. It just keeps going up and down, up and down. It doesn't get close to anything. Does it go all the way up to infinity? No, right? It's just going 1 and negative 1. And since you can't tell me where it's going, you can't say between 1 and negative 1. This is one of those cases where there is no horizontal asymptote. because it doesn't get close to one particular value. Yeah, it changes a little bit. What if I ask for what's the limit as x approaches infinity of x sine x? This is a little different. Because as x gets huge, oh, actually, the same thing. This just goes between 1. It's even worse. This picture is kind of interesting. This picture looks like this. It's got this little boundary, and then your graph of sine does this in between it. So if you're trying to figure out, well, what happens as x goes to infinity of this thing, it doesn't get close to anything either, so you get to say it doesn't exist. All right.